and non-ideal solution showing negative deviation from Raoult's law. First, non-ideal solution showing positive deviation. Liquid solution which show positive deviation from Raoult's law. Suppose there are two liquids, cyclohexane and ethanol, and in cyclohexane liquid there is van der Waals forces, and in ethanol there is intermolecular H bonding, and intermolecular H bonding, intermolecular forces is more stronger than the van der Waals forces. That is, ethanol cannot easily vaporize as compared to cyclohexane, because the lesser the intermolecular force, more is the vapor pressure. Suppose these two liquids are mixed, cyclohexane is mixed with ethanol, then due to mixing of these two liquids, intermolecular H bonding between the ethanol molecule will break down, and the mixture formed having the ethanol and cyclohexane will have weaker intermolecular force of attraction as compared to the force of attraction between the ethanol. So the liquid mixture now can easily get vaporized. It means, suppose we have two liquids, suppose a pure liquid A and a pure liquid B. In pure liquid A, the intermolecular forces are between A and A molecules, and in the B liquid, pure liquid, the intermolecular force are between the B and B molecules. Suppose we mix these two liquid, now the intermolecular force are formed between the A and B molecules, and if the intermolecular interaction between the A and B molecules are less than either of the B and A components, then this liquid mixture can easily get vaporized. And if this liquid mixture formed by the combination of two pure liquids have lesser intermolecular force of attraction, then the liquid mixture can easily get vaporized. And if the liquid mixture which can get easily vaporized will have more vapor pressure as compared to Raoult's law. It means Raoult's law is non-formed and the solution will show positive deviation from Raoult's law. Now, each component of the liquid mixture will have more vapor pressure as compared to Raoult's law. That is, partial pressure of A component is more than the mole fraction of component into P naught A, and partial pressure of B is more than the product of XB into P naught B, and the total vapor pressure is more than the partial pressure of A plus B component. This is because now these two liquid mixture when formed to give A and B, the liquid mixture can easily get vaporized, and if the liquid mixture can easily get vaporized, then it have more vapor pressure as compared to Raoult's law. So Raoult's law is not followed. Then the total vapor pressure of the liquid mixture is greater than the sum of partial pressure of A and B components. First point. Second point. When the pure liquid A and pure liquid B is mixed to form a mixture having the component A and B, will have lesser intermolecular force of attraction. It means the liquid molecules move farther away from each other after mixing, so that total volume change is more than 0. That is, change in volume is equal to positive. Suppose a liquid volume having 50 ml and a liquid having volume 50 ml. Suppose these two liquid are mixed, then total volume is more than 100 ml, because if the intermolecular force of attraction decreases, then the liquid molecule will separate away from each other and the volume of the liquid mixture will increase, and the enthalpy change of the liquid mixture is also greater than 0. That is, enthalpy change is equal to positive, because if the two pure components on mixing will form a solution having solution from Raoult's law, intermolecular force of attraction will decreases and the molecule will separate further away from each other. So energy is required to separate the molecules, so that the enthalpy change of liquid mixture is positive. So if the two components on mixing will have less intermolecular force of attraction, then total vapor pressure of liquid mixture is greater than the sum of partial pressure of A and partial pressure of B component, and volume change also is greater than 0, that is volume change is equal to positive, and enthalpy change is also equal to positive. And if the liquid mixture show positive deviation, then each component will exert more vapor pressure as compared to Raoult's law. So the graphical behavior of Raoult's law for binary solution will also get changed. Suppose we have a binary solution. This type of graph is observed for ideal solution by the liquid mixture, liquid solution having the showing the ideal behavior. Suppose this is the P naught A, vapor pressure of pure component, and this is the P naught B, vapor pressure of pure component, and this slope will show the partial pressure of B component. Partial pressure B is equal to XA into P naught A, and this is partial pressure of A component, mole fraction into P naught A, and this is the total pressure, that is partial pressure of A plus partial pressure of B component. Now, if on mixing the two pure liquid, the intermolecular interaction between the liquid molecule decreases, now each component will have tendency to vaporize easily. So each component will exert more vapor pressure as compared to Raoult's law. So the graphical behavior will change, that is the dotted line will show the vapor pressure of pure components on mixing will increases, and the total vapor pressure of the solution will also get increased. That is the partial pressure of A component is greater than the product of XA into P naught A, partial pressure of B component will greater than the XP into P naught B. Okay, thanks. Next.